Okay, so now it's time to start figuring out how to make some of these calculations. And this idea of keeping track of the uncertainty as we make calculations like addition or subtraction or whatever the math is, that's called propagating the uncertainties. It means taking the uncertainties from a particular calculation or measurement and moving them through the calculations, keeping track of the uncertainty so that we know in the final, when we get our final answer, we know how uncertain that answer is, because that uncertainty will be based on all the uncertainties of all the numbers that we had originally measured. So there's no doubt that the easiest way to do this is just to do it by example. So I'm going to give you an example of two numbers with measurements. We'll do add first. And you'll see something really interesting about this. So we'll do an addition problem, then we'll take the exact same numbers and we'll do a subtraction problem with them. And you'll see that the uncertainty, the absolute uncertainty, actually comes out exactly the same, regardless of whether you add the numbers or subtract the numbers. That's like a really interesting thing. And you will definitely be able to understand the logic behind this. I don't need to do any kind of fancy math or anything like that. It'll be obvious that this is the right uncertainty for this. And ultimately, that's going to allow us to have a rule, so that we won't have to go through what I'm about to show you right now. So my calculation is the following. I would like to take 23.4 plus or minus 0.9, and I would like to add that to 7.7 plus or minus 0.5. Okay. So here's the deal. The first thing I'm going to do is let's just go ahead and do the addition. So 23.4 plus 7.7 is 31.1. Okay, so what we're going to do is very similar thing that we did when we were trying to calculate the uncertainty from a set of repeated measurements. I am going to have the following columns: A, H, or I should say rows, L, R, and U. The final uncertainty. Now, in this case, we were saying that A was the average of the repeated measurements, but in this case, A will be the answer to the calculation, and I already know that A is 31.1. Okay, so my final answer will be 31.1, but plus or minus what? So what we need to think about now is when we make this calculation, when I add the 23.4 and the 7.7, what is the biggest possible answer that I could get from that set of data? Well, obviously, it would be when I add the uncertainties. So this plus this plus this plus this is going to produce the biggest number. Now, there's also the possibility that the number was smaller than what I expected, and that would be what would produce the smallest possible answer. So when I add these two numbers together, if I do 23.4 minus 0.9 plus 7.7 minus 0.5, those are going to give me the smallest values that I can possibly get. So 23.4, focus, there we go. 23.4 plus 0.9 is 24.3. So let's write these down right here. So the largest possible value is 24.3. And the smallest possible value here would be 22.5. 22.5. On the 7.7 side, this could go as high as 8.2, could go as low as 7.2. So my biggest answer is going to come from adding these two guys, which are both bigger than the original numbers. So that's going to give me my high number. So that's going to be 24.3 plus 8.2. That gives me 32.5. My low number would be by adding the smallest numbers I could get with that data, plus 7.2, that's 29.7. Okay, so obviously what we need now is the range of that data. That's the highest possible answer we could have gotten. That's the lowest possible answer. Now I'm going to subtract to get the range, and I'll divide by 2 to get the uncertainty, and we'll be done. That'll be it. So that's 32.5 minus 29.7. That gives me 2.8. And therefore my uncertainty would be 1.4. So the final answer for this one becomes 31.1 plus or minus 1.4. That's an absolute uncertainty. It has the same units as what other numbers are. So if these are like distances or velocities or whatever they are, it'll have the same units as those. Okay? So what I would like to do before I establish the rule, let's just see what happens with subtraction, because subtraction creates this really interesting dynamic where we're going to end up with the same answer for the uncertainty. Now, obviously, adding and subtracting are not the same thing, but when it comes to the uncertainty, it actually doesn't make any difference. So let's take a look at this same problem. 23.4 plus or minus 0.9 minus 7.7 plus or minus 0.5. All right, well, first thing, obviously, let's just get the answer to this. All right, so that's 23.4 minus 7.7. I believe that's 15.7. Oh, sorry, hold on. 23.7 minus 7. Oh, that's not right. 23.4 minus 7.7. There we go. 15.7. Okay, so that is our answer to the calculation. Now, what are the highest and lowest numbers? Well, I've already done this for the... We already have our high and low numbers up here. So the difference is, now when you think about the subtraction, you really have to think about this carefully. How do I get the biggest answer from this? Well, the biggest answer is going to come from taking the biggest possible value for 23.4, which would be 24.3, and taking the smallest value of the other one, right? Because the idea, in order to get the biggest range, what I need to do is take the high and low numbers and move them as far apart as they can be from each other. And the way I would do that is by making the biggest number bigger and the smallest number smaller. So big number bigger, smaller number smaller. That's going to show me what is the biggest possible range that I could get using that data. So that's different than what we did before, right? Because we added both to get the biggest number and subtracted both to get the smallest number. But now when we do subtraction, it's a little bit trickier, and you're going to find the same issue occurs when we do division. So my biggest number, my highest value, is 24.3 minus 7.2, which gives me 17.1. My lowest possible value would be done by taking the smallest possible value from the top number and subtracting the biggest possible value, and that's going to draw those closer together and make that range, that number a little bit smaller. So 22.5 minus 8.2 gives me 14.3. All right, let's go ahead and subtract those two. 17.1 minus 14.3, and guess what? It's 2.8. And therefore the uncertainty is 1.4. So the answer for this one is 15.7 plus or minus 1.4. And that's it, we're done. Now notice we got the same uncertainty. And let me show you where we could have gotten that uncertainty from, right here. 0.9 plus 0.5 is 1.4. So actually, we don't need to go through this whole business. We don't need to use the range method, although the range method, what we just did for addition and subtraction, is the underlying principle of all uncertainties. All uncertainties work in the same manner. But because it turns out that they produce the same results, we can now create a general rule. So for Q plus or minus, let's do it this way. So let's say for delta Q is equal to delta X plus delta Y. Essentially, the way we'll get the uncertainty for the answer is by just simply adding the two absolute uncertainties. Super easy. They'll have the same units. So this is 1.4 in the same units as the original measurements. But essentially, all we need to do is to just add these two together, and we get the fractional uncertainty. And that's obviously much easier than going through the range method. So while the range method works, and it's sort of the underlying principle, I would definitely not use the range method for addition and subtraction, because the rule is really very simple. So here, Q would be equal to X plus or minus Y. It doesn't make a difference whether we add or subtract the two numbers, X and Y, together. The uncertainty is going to say add the absolute uncertainties. Add those absolute uncertainties. Even in a situation where you subtract, you would still do it. I know that's a little confusing because I don't mean plus or minus. I mean that this is a calculation where either we're adding two numbers together or we're subtracting two numbers together. I'm not giving the uncertainty. I'm saying the calculation, 15.7, came from two numbers, X and Y. that I either added or subtracted, and regardless, I got the same uncertainty. And that's it for adding and subtracting.